Hey guys. Oh, I'm showing you way too much already. Anyway, I just want to do a quick little video. Hopefully you guys enjoyed your snow day today. I was just going to set this up tonight. You guys have to do it tomorrow. Have it Thursday, but I was bored. So this is what I got going for you. We're going to take a look at possible rational roots that we talked about yesterday. I felt like we had to get everything done so quickly. So I just wanted to put an example out there for you. I did read your notes, and a lot of you said you like the notes taped. So I'm just going to go over a quick example with you. All right. So remember the P divided by Q, and I said you don't really ever need to remember the P divided by Q. We just need to know factors of 14 divided by 3. All right. So factors of 14 are 1, 2, 7, and 14. Again, don't forget the plus or minus. I did add in, I'm just going to erase this because we don't have a plus or minus of 0. 0 is also a factor. I forgot to list that yesterday. And then the factors of 3 are 1 and 3. All right. So the first question is, what is the number of complex roots do we have for this problem? So if we take a look here, all right, our degree of the polynomial is the number of roots that we will have. And again, complex means that we could have imaginary and rational. Okay, we've got radicals in there, we have lots of stuff. So the other question is list all your possible rational roots. Okay, so again, when we're doing this, we take each number 1 divided by 1, 1 divided by 3, 2 divided by 1, 2 divided by 3. We go through, and I lost a few. 1/3, 2/3. What did we lose? Plus or minus 1 1/3, 2 2/3, 7. I missed a 7/3, right? And then we have plus or minus. Oops, sorry. Plus or minus 14, right? And then plus or minus. Sorry, you guys, let me just erase this because it's a mess. Sorry. Someday we'll get rid of this little thing here. 7/3 plus or minus 14 plus or minus 14/3 and 0. Those are all our possible rational roots, all right? So I'm going to give you guys a second or two or however long you need. I want you to pause the video. I'm not going to do it on Edulastic. I just want you to pause it, and I want you to find, there, I'm just going to give you a hint, there are going to be 2 of these that work, all right? So take your time, figure out what they are, and then when you're ready, press play again. All right, so I'm assuming you figured out 1/3 works. All right, so with 1/3, here's our coefficients. We bring down the 3. We bring down the 3. 3 times 1/3 is 1. We get to 6. Gives me 2. Negative 21 gives me negative 7. Oh, I got 23 written in there twice. Sorry. Hold on, let me fix that. It's going to annoy me. There we go. So much easier. All right, I got negative 42. And then I get negative 14, which gives me my 0. Now, remember, when we're talking about this, we divided by 1/3, which means I have to take each one of these and divide it by 3. All right, we started with a 4th, so we have x to the 3rd plus 2x squared minus 7x minus 14. Okay, that's what we have left. Now, what do you think? Did you figure out your other one? All right, our other one that worked was negative 2. Now I'm going to use this function because I already did one division, so I got it down to a cube. Once I get it down to a cube, I go one more time, I get it down to a quadratic. So there's my 1. This is my -2. I get a 0. I get a 0, I get a -7, and I get a 14, and I get a 0 left. So again, my factors right now are 1/3 and -2. Well, I need 4 of them. So this tells me I'm left with x squared minus 7 because there's 0x in the remainder. When we're solving for roots, we take x squared minus 7, we set it equal to 0, we get x squared equals 7, and we get x equals plus or minus the square root of 7. All right, so our solutions here, 1/3 -2 plus or minus root 7. All right, so I took the 4th power, I found one root, got it down to a 1/3, found another root, got it down to a quadratic, which I can factor or solve. All right, if you get it down to a 3rd power and you can group, you're down there as well. All right. All right, hopefully this helps. And again, I'll be on Zoom tomorrow if you guys are having any trouble. All right, have a great night.